Okay, so let's talk now a little bit about whether this is a one-tailed test or a two-tailed test. Um, and I don't know if you're a cat person or a dog person. I'm better at drawing dogs, so I made a little doggy here. So when it really depends on a couple things. So first of all, let's talk about our null. Our null always has to be equals, okay? So our mean, let's say, I don't know, whatever that is, 40. If my alternate hypothesis uses a greater sign, okay, then that means I'm going to be on the right side. This is going to be a right-tailed test. Okay, so we are going to be looking at the right tail if it's just greater than. Now, what is my critical value? That's going to depend on alpha. We also call it significance level. Okay, so if my alpha is 5%, that means that the cutoff here is going to break our distribution to 95%, which is non-critical over here, and 5%, which is critical. Okay, and this is going to be a right-tailed test. This is my CV. This is my critical value. I am looking for this region over here. I want to clear that. I want to clear that 95%. That comes with a z value. Now, if my null hypothesis, let's look at another one. If my null hypothesis has a less than in it, so if my mu is 40 and my alternate hypothesis is less than 40, then I am having a left tail. Now, if my alpha is now 1%, okay, then it's going to be 1% under the curve over here. 1%, I'm going to write it above. I don't have room to write it inside. And the rest of this non-critical region is going to be 99%. Okay, and that's going to be my critical value, my CV. Obviously, if your critical value is on the right side, it's a positive z-score. It's on the right side of the mean. If your critical value is on the left side, then that critical value is going to be negative. Okay, and now just really quickly, the definition of a one-tailed test, it just means that indicates that the null hypothesis should be rejected when the test value is in the critical region. It's in the critical region on one side of the mean. A one-tailed test, it can be either a right side or a left, right-tailed or a left-tailed, depending on the direction of the inequality of your alternate hypothesis. Okay, and then the critical value you go and you find in your z table based on, if this is 1%, then you're going to be looking for 0.01, and if this is a 5% over here, then you're going to be looking 0.95, as close to 0.95 as possible in your chart. Okay, let's talk really quickly about a two-tailed test. A two-tailed test is different because when we are looking at our, our null is going to be the same. It's mu equals 40, okay? But our alternate hypothesis is actually going to be not equals 40, okay? And if it's not equals 40, then if this is my 40, okay, then I am somewhere on the size of it. And again, I need my alpha. Let's say that my alpha over here is also 5%, and we'll work with that. If my alpha is 5% and this is not equals, then I need to break that 5% into two tails. Okay, so that means that each tail gets 2.5%. Okay, this tail gets 2.5%. Okay, and that tail also gets 2.5%. Right, that leaves me with 95% in the middle, just like we did in confidence intervals. Remember, the confidence intervals were about the mean. So the rest of this is 95%. So if I'm looking for my critical value in the table now, I either have to go look for 0.025, or I have to go and look over here to this critical value, this CV, which is going to be 2.5 and 95% together, which is 97.5%. And these critical values should be roughly the same thing. Okay, so if we are conducting a two-tailed test, the null hypothesis can be rejected in both cases. If your critical value is in this case, in this area, or it is in this area. Okay, your critical region is going to be separated into those two parts, each having a half of alpha. Okay, so this over here is alpha over 2, and this over here is alpha over 2. Together, they're going to be making up my 5%. Okay, and that's essentially the difference between a one-tail and a two-tail test.